right, folks, let's check to see out where you're at. We are looking at let's see here, math induction. I think that's where we're at. And let's see where you got. You did. Oh, wow. That sounds really scary. Yo, let's check out our this is the math induction problem you're given. Let's see where you end up. You got the sum from 1 to n of 2k minus 1 is supposed to be equal to n squared. And it simply means this. If you take the certain number of odd integers and add them up, it's that number squared. So for example, if I want the sum of the first 5 odd integers, I just take 5 and I square it. 5 squared is 25. So if you notice, 1 plus 3 is 4, plus 5 is 9, plus 7 is 16, and then plus 9 is 25. See how that works? So sure enough, we test. Try case 1. Got it. Try case 2. Got it. Try case 3. Got it. Is everybody okay with going through the first case? Then the second case is assume that it's true for case n equals k. So we write out the same thing. 1 plus 3 plus 5 plus 7 plus dot 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 plus 2k minus 1 is equal to k squared. So we write the same thing down that we had up above. It's just we put a k instead of an n. So then the third step, and that seems to be where people are kind of getting lost, is show it's true for n equals k plus 1. So I start off the same way. 1 plus 3 plus 5 plus 7 plus dot dot dot. And I want to be clear, this is the first term. This is the second term. This is the third term. This is the fourth term. You're also going to write the kth term and then the k plus 1 term. What is the kth term? 2k minus 1. And then, what is the k plus 1 term? Is equal to, well, the number of terms that we've added up squared. So what is the number of terms we have now? K plus 1 terms. So that's what we want to show is true. So let's go about showing that that is true. We will always use that portion. That is k squared. Is everybody clear that those two things are the same? So I could take k squared and drop it in. So k squared plus 2 times k plus 1 minus 1 is supposed to be equal to k plus 1 quantity squared. Now it's a matter of making the left look like the right. We have k squared plus 2k plus 2 minus 1 is equal to that. Well, that's k squared plus 2k plus 1. It's supposed to be equal to that. Does that factor? Factors to k plus 1 quantity squared. There you have it. Want the good news or the bad news? Bad news, that's the easiest one I can give you. You can't get an easier one than that. Good news is that in the other hours, people felt like they definitely understood it better at the end of today than they did at the beginning of yesterday. All right, so let's look back at our beginning. It says the sum from 1 to n of this thing is equal to that. So we plug in 1, we plug in 2, plug in 3, plug in 4. Our last one we plug in n, okay? And we plug in n, you get 2 times n minus 1, right? Well, now what this is saying is it says that we want to plug in k. So if you plug in k, you get 2 times k minus 1. And then if you, yeah, you're plugging that into the rule. You must plug it into the rule. You're ready to try one on your own. Because you are super smart. The best of the best. Bunch of geniuses. There you have it, folks. You try this one on your own. The sum from 1 to n of 3k minus 2 is 3n squared minus n all divided by 2. Sum from 1 to n of 3k minus 2 of 3n squared minus n divided by 2. Any questions? Everybody got it written down? You start with 1, then 2, then 3. All right, for those of you watching on YouTube, sorry I didn't record this when we went through, but here's a, well, here, I'm just going to slowly put it up here so you can see the steps that were taken. Sad faces where people generally get stuck, and you got to do that little trick there. And that's how it works. So YouTube, you can slow it down, run it back. We're going to go ahead and do one more. We're going to take the sum from 1 to n of k squared, and that's going to be equal to n times n plus 1 times 2n plus 1 all over 6. And I need you to be on your A game here. We got this is a little bit more challenging. So you're ready to move into the level 2 problems now. So we're saying goodbye to level 1. We're ready for level 2. Yeah, your calculus stuff. You're going to do just fine on that test. What do I plug in first? 1 squared is 1 plus 4 plus dot, 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 dot. What does it say the last thing I plug in is? N. And I get n squared is equal to n times n plus 1 times 2n plus 1 all over 6. That is the claim. How dare they make a claim? Let's prove this claim. Proof by what? Induction. Oh, it's a beautiful thing. Boom. First step. Show the rule holds true for the first few terms. Mathematics just need one counterexample and then everything falls apart. Case 1. Somebody tell me. What do I do? 1 equals 1 times 1 plus 1 times 2 times 1 plus 1 over 6. Does that work? So I get 3 times 2 is 6 times 1 is 6 divided by 6 is 1. Did it work? All right. I'm not convinced. I need to do case 2. Now what do I add up? 1 plus 4. So that's 5. And so then what do I plug in for n? No, I don't plug in 5. I did 2 terms. It's case 2. So I got 2 times 2 plus 1 times 2 plus 1, all over 6. Yeah. So we get, 5 times 3 is 15, times 2 is 30, divided by 6 is 5. Did it work? I'm convinced. Then either you made a mistake or the rule is wrong. Then if you show a counterexample, then you've proven it false. You've said your claim is false. Yep. All right, assume the rule holds true for case what? N equals K. What does that look like as I write it out? Plus K squared is equal to? Third step. And this is where it starts to fall apart for people when you write this out. Let's make sure we get this straight. A lot of questions have come up today about how to write this out. 1 plus K squared plus K plus 1 squared. So I had 1, 2, 3, 4. It's the K term. It's K plus 1 term. K plus 1 times K plus 1 plus 1. 2 times K plus 1 plus 1. It's okay to say ugh. Yeah, no, I agree. I agree. It's something you get used to. Fortunately, you guys are extremely intelligent. Shubashma. Shubashma. Okay. All right. You can definitely formulate opinions about it. It will not change. The cool thing is it's perfect. It works out every time. So as I begin step number 3, I look at that piece. Do we have that somewhere else on the board? Right here. What is it equal to? Oh, it's that guy. And it gets dumped right there. Whoop. I'm being dumb. Sorry. My mind was wandering. Yep, it is. Mark it wrong. Yeah, so I'm not adding extra stuff here for teaching purposes. Like everything I'm doing is like maybe those red numbers, like that's extra for teaching purposes. Yeah, we don't want to do that. Nope. All right, so I made that one substitution. Everybody agree we find common denominators? K times K plus 1 times 2K plus 1. And then I got multiplied top and bottom by 6, right? So plus 6 times K plus 1 squared. Now, folks, you have to trust. You remember last time you saw something on the right side? You're like, how will we ever make the right side look like the left side? how will we ever make the left side look like the right side? You took a glance over at the right side. You're like, oh, I need a negative k and a negative 1, right? So just trust it. There's a lot of ways to go through this. I know people on YouTube, if you're watching, say factor. Got it. I think that where we're at right now in this time of year, it's gonna be best to just give you one method for solving all this. And I'm just gonna multiply it out and create one polynomial and go from there. You okay with that? Okay, so let's multiply this out. K times 2k times k will be 2k cubed. Then I've got 1 times 2k, and 1 times k is going to give me 3k times k. One times 1 times k. What is k plus 1 quantity squared? So it will be 6k squared plus 12k plus 6. Two k cubed plus it turns out that that thing right there is supposed to factor to that right there. Tough to see, isn't it? Fortunately, we're really good with it. What can we take out? See, she looks and she says, I know I can take out a k plus 1. So just take out the k plus 1. And I know all of you are looking at it, you're like, well, fine, take out the k plus 1, but what the heck is left? You learned how to do this first semester, chapter 3. You did it last year as well. Yeah, just take the negative 1 and drop it in synthetic division. You got the 2, 9, 13, and 6, right? 2, 9, 13, and 6. Drop the 2. Yeah, k plus 1, so the root is negative 1. So drop the 2 down. Negative 1 times 2 is negative 2. Add 7. Multiply. Negative 7. Add 6. Multiply. Negative 6. Add 0. So what do we get that remains? We get 2k squared plus 7k plus 6. Is it starting to look more like the right-hand side? Do you think you can factor that 2k squared plus 7k plus 6? I hope we can. I guess I got a 2k and a k. Six and 1, 3 and 2, 2 and 3, 1 and 6. What do you think? Plus 3, plus 2. Oh, hey, wait a minute. It looks like on the end here, looks like I got a k plus 1, don't I? That's like k plus 2. And it looks like on the end over here, I have 2k plus 2 plus 1, right? That's like a 2k plus 3. So maybe if I just do this, maybe I just show one more step in here. Maybe I just go k plus 1 times 2k plus 2 plus 1 times k plus 1 plus 1. I mean, I think that whoever's reading this proof, that they would be able to understand that step there. Don't you agree? And so all I have to do now is one last little factor. What do I have to take out? Yep, 2 times a k plus 1 then plus 1 times k plus 1 plus 1 all over 6. Synthetic division can be our friend. Pretty neat, huh? Be ready for Monday because you want to practice. Test is on Tuesday, and trust me, it's going to go wonderful. Reason